Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Mr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, shall be concluding limiting and excess reagent in stoichiometry. We've solved a lot of questions on stoichiometry, and this video will be the concluding part of it. So we have one of the questions on the board. It said, aluminium reacted with iron 3 oxide to produce what? Aluminium oxide and what? Iron. They said 124 gram of aluminium was reacted with what? 601 gram of iron 3 oxide to produce what? Aluminium oxide and iron. Before we look for this A and B, we first have to determine the limiting and what? Excess reagents. I told us in our initial class that limiting reagents are reagents or they are reactants that are used up first in a chemical reaction, which means when reactants are exhausted, when they are used up in a reaction, it means a product will not be formed. So before we look for the mass and how much of the excess reagent is left, we have to determine the limiting reagents of this equation. So let's get started. Now they gave us 124 gram of aluminium. So what do we do? Just as we did in our initial class, we have to look for the number of moles of aluminium as well as the number of moles of what? Iron 3 oxide. So let's take it. You know the number of moles is equals what? Mass over molar mass. Is that not correct? So the mass from the question given, the mass for aluminium given is what? 124 gram over. What about the molar mass? The molar mass of aluminium, that is the atomic mass, as the case may be, is what? 27. 27, okay? So let's divide. 124 divided by 27. 124 divided by 27, I'll have 4.59 moles. 4.59 moles. Then from this place, going back to the equation, what will you see? You see 2 mole of aluminium, 2 mole of aluminium will give 1 mole, because you only have one here, an invisible one. So 1 mole of aluminium oxide. All right. Then how many mole of this will produce this? Which means that 4.59 moles of aluminium will produce how many mole of aluminium oxide? So X mole of what? Aluminium oxide. Alright, so after that, what do we do next? You cross multiply. In cross multiplying, you'll be having X mole equals this times this. You say this times this divided by this, right? So you say 4.59 times 1 is the same thing as what? 4.59 divided by what? 2 moles. So we have 4.59 divided by 2 equals 2.295 moles of aluminium oxide. So this is the first case. It means that from what I've just done, we can deduce that 2.295 moles of, okay, no, let's come back to the question. It means that 124 gram of aluminium, all right, will produce 2.295 moles of what? Aluminium oxide, all right? But that is not just the final step. We are also given for iron 3 oxide. So let's take it normally. So number of moles is equals what? Mass over molar mass. The mass given from the question is what? 601. Let's look for the molar mass of of iron 3 oxide. This ion has atomic mass of 55.8 times 2 plus oxygen is what, 16, right? So 16 times 3, you have what, 48. So plus 48 equals, you have 159.6. 159.6. So what do we do now? 601 divided by 159.6 equals, I'll have 3.77 moles approximately. 77 moles approximately. Are we done? No, we aren't. What do we do next? It means that 1 mole of this means that 1 mole of Fe will produce 1 mole of this. Then how many moles of this will form that? You will have 3.77 moles of, will form how many moles? X mole. Remember, what we just calculated is aluminium. This one is for aluminium. Don't forget that. It was aluminium that gave 2.295 moles of this, okay? So what do we do next? We cross multiply. So X mole is equals this times this, which means 3.77 times 1 is the same as 3.77, right? Divided by 1, the same thing. So X mole equals what? 3.77 moles of aluminium oxide. So from what we just did, aluminium gave 2.295 moles of aluminium oxide. Is that not correct? Then iron 3 oxide gave 3.33 moles of what? Aluminium oxide. So from what we've gotten, we got two values. Looking at it properly, which of them do you think is the limiting reactant or reagent? 3.77 and 2.295. Which of them is the biggest? 3.77 is the biggest, while this other one is the smallest. Therefore, the limiting reagents in this reaction is aluminium because it produced the smallest amount of moles of what? Aluminium oxide. I take it again. The aluminium oxide is called the limiting reagent because it produced the smallest amount or the smallest moles of what? Aluminium oxide. While this one is the excess reagent because it produced 3.77 moles of what? Aluminium oxide. So that is the first step. Now let's now take the second one, which, okay, I can make this B and here C. Of course, in the initial class, I told us to solve this and then drop it on the comment section. I don't know if we have solved it, but let me just solve it. So B says we should calculate for the mass in gram of what? Aluminium oxide. Aluminium oxide. Okay, where is the board paper? God of Nazareth. Sorry. So we'll rub off this first part of it. Oh, the limiting reagent, I've rubbed it off for 2 point what? 2.2, that should be 2.2, okay, 4.59 divided by 2 equals 2.295. We are going to be needing it, so that is why I have to write it out again. Okay, now we have to look for the mass in grams of what? Aluminium. In looking for the mass of aluminium, of course, you know that number of moles is equals what? Mass over what? Molar mass. If we should make the subject of the formula, what I'm going to be having, we'll have that M is equals number of moles times what? Molar mass. Is that not correct? So mass is equals the number of moles is a limiting reagent, which is 2.295 times the molar mass of aluminum oxide. So let's check. Aluminum is 27. Yes, aluminum is 27 times 2. You see, it's having subscript 2. So, which means that is 54, yeah. 27 times 2, that should be 54. 54 plus 48 equals 102 times 102 times 102. Therefore, it means that the mass is equals 2.295 times 102 equals 234.09 grams. So this is a mass of what? Aluminum oxide. So how much of the excess reagent is left at the end of the reaction? How much of the excess reagent is left at the end of the reaction? What is the excess reagent calculated? Excess reagent, I think we add this to be the excess what? Reagent, okay? Which means we are talking of grams now. Quantity, how much quantity? We have to look for, I think we had the molar, what did we get again under the molar mass of aluminum oxide? We had 55.8 times 2 plus 48 equals, okay, 159. So 159.6 gram of this produce how many gram of aluminum oxide? I think we have to be 102, right? 102 gram. No, let me check it again, please. Sorry, it's good. So 54 plus 48. No, yeah. Okay, so it's correct. 102. So S gram. I think we had the molar mass. The molar mass of aluminum oxide, right? So it means S gram of this means that S gram of FeO3 will produce what? 234.09 gram of what? This. So there's no space, but just note it is. Okay, let me rub off this one. So what do we do next? We cross multiply as usual. We cross multiply. So in doing that, you say this times this divided by, that is, you have to cross multiply. So which means that S gram is equals this times this, 159.6 times 234.09 divided by, is that okay, divided by 102 gram. Okay, so what do we get? 159.6 times 234.09 equals, okay, divided by 102. So S gram becomes 366.282 gram. All right, so the gram of iron 3 oxide now is what? 366.282. All right, while that of aluminium is what? 234.09. They said how much of the excess reagent is left. Being, of course, it's going to be OBJ exam. Do not be too quick to pick this thing. It's very dangerous. They said how much of it is left, all right, at the end of the reaction. For you to know the quantity of the reagents that is left at the end of the reaction, take your mind back to the question, all right? We just got 366.282 gram of what? Iron 3 oxide. Now from the question, we are given 601 gram of what? Aluminum. Okay, iron 3 what? Oxide. So what are we going to do? We look for the difference between this and this. So that will give us what? The one that is left at the end of the reaction. So it means that S gram now is equals 601 minus 366.282, which means that S gram is equals 601, means that 601 minus 366.282 equals 234.718. all right, therefore this is the amount that is remaining at, or that is the reagent, the excess reagent that is left at the end of the reaction. So this is the final answer, and please, if you know you have learned something in today's video, endeavor to subscribe, like, share and comment. If you have other questions that get you perplexed, or perhaps solving it you got stranded somewhere, just type it on the comment section and I will receive a notification. That is if you subscribed. Yes, those that actually have subscribed, when they drop anything on the comment section, YouTube gives me a notification. That is why it's also good you subscribe, so that whenever I upload a new content, you will be aware. Okay, so you'll not be left behind. So at this point, we'll call it a day. Thanks for watching. Do have a wonderful day. Happy Sunday.